All right, so in this problem, we have the square root of 3 to the power of x is equal to 81. Now, to solve this, I'm going to start here with the square root of 3. So let's just ignore everything else for a second and focus on the square root of 3. Now, the square root of a number is, say, the square root of x. This is the same thing as x to the power of 1/2. Because basically, the root here is 2, but we just don't write that. And the cube root of a number, that's that number to the power of 1 over 3, because we have a 3 over here. So the square root of 3, we can think of 3 as x in this case, and we can rewrite this as 3 to the power of 1/2. So now, if I substitute in 3 to the power of 1/2 for square root of 3, I get 3 to the power of 1/2 to the power of x is equal to 81. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 1/2 to the power of x, that's going to equal 3 to the power of 1/2 times x, which is simply 1/2 x. And this is equal to 81. Now, 81, that's the same thing as 3 to the power of 4. So now I have 3 to the power of 1/2 x is equal to 3 to the power of 4, and this means 1/2 x is equal to 4, and x is equal to 8. So 8 is my answer. Alright, so in this problem, I have 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. So I'm going to first start by rewriting 20 as 19 plus 1. So now I have 2 to the power of 19 plus 1 minus 2 to the power of 19 is equal to 16 to the power of x. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 2 to the power of 19 plus 1, and this is going to equal 2 to the power of 19 times 2 to the power of 1. Now I have this minus 2 to the power of 19 is equal to 16 to the power of x. Now from here, if I factor out 2 to the power of 19 from my left-hand side, I get 2 to the power of 19 times 2 to the power of 1 minus 1 is equal to 16 to the power of x. And 2 to the power of 1 minus 1, that's simply equal to 1. And anything times 1 is itself. So I have 2 to the power of 19 is equal to 16 to the power of x. Now, 16, that's the same thing as 2 to the power of 4. So now I have 2 to the power of 19 is equal to 2 to the power of 4 to the power of x. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 4 to the power of x, that's going to equal 2 to the power of 4 times x, which is also 2 to the power of 4x. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 19 is equal to 4x. Now we have a simple equation here. All I have to do is divide both sides by 4, and I get x is equal to 19 over 4. Now, to check, my original equation was 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. Now, 2 to the power of 20 minus 2 to the power of 19, we already know that's 2 to the power of 19. So we get 2 to the power of 19 is equal to 16 to the power of 19 over 4. Now 16, that's the same thing as 2 to the power of 4, so now I have 2 to the power of 4 to the power of 19 over 4, And these two 4's cancel out, so I get 2 to the power of 19 is equal to 2 to the power of 19. Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 333. So, the first thing I'm going to do is factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times 1 plus 1 plus 1 is equal to 333. Now, I'm going to solve what's in my parentheses. So I have 1 plus 1 plus 1, that's equal to 3. So now I get 3 to the power of x times 3 is equal to 333. Now, we want to isolate 3 to the power of x here. And the way to do that is to get rid of this times 3. So I'm going to get rid of this times 3 by moving it to the right-hand side, and I'm going to do that by dividing both sides by 3. So now I get 3 to the power of x 3 to the power of x is equal to 111. Now, if I take the log on both sides, I get log 3 to the power of x is equal to log 111. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 111. Now if I divide both sides by log 3, these two cancel out, and I get x is equal to log 111 over log 3. Now, I can write my solution in two ways. The first of which is to actually divide log 111 by log 3. So log 111 divided by log 3, this is equal to 4.29. So this is one way I can write my solution. Now another way I can do this is if I have something in the form log a over log b, this is going to equal log base b of a. So this is another way of writing my solution. Alright, so in this problem, I have x to the power of x to the power of 3 is equal to 36. So to solve this problem, I'm going to first start by taking the power of 3 on both sides. So now I have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And notice that for multiplication, I can switch the places of these two numbers. So this is the same thing as a to the power of n times m, right? Now, if I have something in the form a to the power of m times n, and this is equal to a to the power of m to the power of n, then a to the power of n times m, this should equal a to the power of n to the power of n. Meaning, all four of these are equal to each other. So my point for telling you all of this is that a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So now coming back over here, we have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. And we can think of x to the power of 3 here as m and 3 as n. So now I can switch the places of these two. So now I get x to the power of 3 to the power of x to the power of 3 And this is equal to 36 to the power of 3. Now from here, I'm going to rewrite 36 as 6 to the power of 2. So now I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 2 to the power of 3. And again, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So this is the same thing as x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 2 times 3. And 2 times 3, that's equal to 6. So I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 6. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, x to the power of 3 is equal to 6. And now if I take the cube root on both sides, I get x is equal to the cube root of 6.